So as we left off in our last video, we talked about this idea that we can do definite multiple integration. So what we're going to take a look at here is we've got an integral that is in terms of x, but my bounds can be in terms of their functions of whatever my constant variable is. Any variables that are a part of this function that are not our current variable of integration can be a part of the functions in my bounds. Notice the variable that we're integrating with respect to cannot be in that function that our bounds are in terms of. So an example we could do, well, we just took the antiderivative of this 2xy function. Now I can do the integral of 2xy, the definite integral, from, say, the function 4, a scalar is still a function, to the function 3y. So notice it's okay that one of my bounds is in terms of y because we're doing the integral with respect to x. So as we saw in our previous video, when we're taking a look at integrating 2xy, remember when you do definite integrals, you still do the antiderivative and then you evaluate it at the bound. So when I do the antiderivative, I'm going to pay attention to where's my x and treat anything else as constant. So essentially this is 2y, which is a constant, times x. So x is going to move up to x squared. We'll keep the constant y. We'll also divide by that new power of 2, which cancels out this 2 over here. So we end up with x squared y. And we're going to evaluate that from 4 to 3y. When we evaluate this, remember we're going to plug in our bounds. So we're going to go ahead, we plug in the top bound first. So I'm going to plug in 3y. Now notice we're plugging that in to my variable of integration. We're plugging it into x, and everything else that's constant stays constant. So I really have 3y squared times y, and then I'm going to subtract off the lower bound. So I'll subtract off 4 squared times y. So simplifying that, notice we're going to get 9. We've got y squared times y, which is y cubed, and then we've got minus 16y. So you'll notice that it's a little different than what we had in the past, because when we did definite integrals in the past, we always got a scalar, right? We thought about that a definite integral represented an area under a curve. Well, if we think about it, that analogy still holds here, because notice what we got, while it is a function, it's only a function of y, which was my constant variable in this case. So in a sense, we still got something that's considered constant with respect to x. So it still works in that sense of being able to do this definite integral is giving us something that's constant. Let's try another example. We can work through this one maybe a little more quickly. Let's try the integral from 1 to x of 4xy plus, we'll do e to the x, and this time we're going to do it dy. So notice now my variable of integration is y. So it's okay that in my bounds I have a function that's in terms of x. Now in both of these examples I've happened to do a constant, a literal scalar to a function of the variable. That part doesn't matter. Both bounds can be functions of the variable. Both bounds can be scalars. As long as your variable of integration doesn't show up, it's all good to go. And we're going to see examples later of why you might choose bounds the way that you do. And that will be based on, like we saw, we're going to do some area questions later on. So let's take a look at this guy. So when we think about integrating it, we're going to think about how my variable of integration is y. So anything that's in terms of x, we're going to treat as a constant. So really this is 4x, which is just a constant, times y. So all we're going to do is we'll integrate y, which goes to y squared over 2. So 2 and the 4 will cancel 2 and 2. We keep the x and we end up with the y squared. And then we might be tempted here to think, all right, well, I'm integrating e to the x, the rule is it stays the same, but no, because at the moment my variable of integration is y, and so when I integrate e to the x, it's really just integrating a constant. So all that happens is you keep that constant and you multiply it by y. Now when we think about this, our next step, notice we had bounds, so we're going to keep bounds. We're going to evaluate that from our lower bound of 1 to our upper bound of x. If this was not a definite integral, if it was an indefinite integral without bounds, on the end of this we would have had a plus a constant function of x in this case, because that was my constant variable, so it would have been a plus c of x for this example. But we do have bounds, so we can plug them in. So we can see what we get if we plug them in. Remember, plug in the top one first, and notice we're only plugging it into the y's because that's my variable of integration. So we're going to have 2x times x squared, so we'll really have 2x cubed, and then we're going to have plus, we have to plug it in here as well, so we'll have e to the x times x. I'm just going to rearrange that and put the x in the front. So x times e to the x, and then we subtract off, plugging in the 1 entirely. So we're going to have minus, when you plug in to the first piece, we just get 2x, and then we'll have minus, plugging in 1 to the second half just gives me e to the x. So all in all, we end up with 2x cubed plus x e to the x minus 2x minus e to the x. Again, notice that if we take a look at what we got there, we got entirely a function of x, which in this case was my constant variable. So therefore, we're viewing this as a constant function with respect to y. Now, a cool thing that we can think about from here is, notice we could now integrate this function with respect to x, right? We got a new function, it's only in terms of x. We could now do a second integral integrating this function with respect to x. What that could look like, for example, then, I'm going to kind of write it from the beginning because this is going to prompt how we're going to look at things later. We could notice that whole integral up top, that integral from 1 to x of 4xy plus e to the x dy. That whole thing really is just this function of x. I could then take another integral of that function of x. Now notice at this point, this new function of, in terms of x, is no longer a multivariable function, it's a single variable function. So when we think about constants for that function, they are going to be literal scalar constants. So for example, I could do the integral from 0 to 1. Now this looks a little bit confusing on the front end, but if we think about using what we just found, well, what we just found was that everything inside of the brackets was just the same as 2x cubed plus x e to the x minus 2x minus e to the x. And then we're taking that, we're doing the integral from 0 to 1 dx. Notice all I did was take what was in the brackets and replace it with its antiderivative, its definite integral that we just found that was all plugged in. And now this is just a classic Calc 1 question. This is something we've been doing for years at this point. So why don't you guys try and finish that one real quick, and I'll jump into the next video with the answer for you. And then we'll kind of take a look at how to write a question like that in a little bit more of a synchronized and shortened way, how we're normally going to see this. So go ahead and try and finish this one, and we'll jump back on here in just a minute.